FTC Intro 18264, the electronovas. In today's video, I'll be talking about creating an autonomous-based program using encoder counts. If you're watching this video, I'll assume you already know how to do the basic stuff, such as get your hardware devices and basically use very simple FTC Java. So I'll basically skip over this part, declaring our motors and getting our hardware devices, and jump. Actually, we'll start right here. So right here, I've set all our motors to the run using encoder mode because that's what we want to use when we're using encoders. I feel like that's pretty self-explanatory, and should ensure to do that every single time you're planning to use your encoders with your motors. So for this program, I've made a method that calculates the distance you need to travel and the rotations needed and all that fancy stuff to travel the distance you want to travel. So before we do anything, we have to ensure to stop and reset our encoder counts. And why we do this is to ensure that all their values are at 0. Because if an encoder count value is not 0, then it can have discrepancies in the desired outcome we want at the end of our autonomous program. So how I've done this is I've basically created a variable called rotations needed, which is up here, rotations needed. And rotations needed is basically the amount of wheel rotations needed to travel a certain distance. And to figure that out, we can simply do the distance, which is a parameter in this method, and divide that by the circumference of our wheel, which would give us the amount of wheel rotations needed to travel that distance. So the circumference of my wheel is 11.86 inches, and it'll vary per person to person, so ensure to check what size your wheel and the circumference of your wheel is. After we figure out the rotations needed, we must convert that into tick counts. And a tick count is basically the amount of ticks it takes in a motor to complete a full revolution, right? So for my motor, the tick count is 537.7. And so again, this will vary per motor and per encoder. So you must ensure check what encoder you're using and what motor you're using and adjust this value accordingly. Another thing to keep in mind is a possible gear ratio that you might be having on your drivetrain. We have a 1-to-1 ratio, so we don't have to worry about this. But if you were to have like a 1-to-2 ratio, you have to ensure to multiply the ticks count by 2, because it takes twice the amount of ticks, twice the amount of rotations to get the same value as you would with a 1-to-1 ratio. So what I've done here is I've just figured out the ticks needed, which would just be the amount of rotations our wheel needs to do, and multiplied by the ticks count, because the ticks count is the value that is outputted per revolution of the motor. So after we figured that out, we basically need to tell the motors to run to these number of ticks, which will take us to the desired position we want to go to. So to do that, we use this set target position method, and then plug in this variable in ticks needed, and that basically tells the motor you need to run to these many ticks because to reach your final position. And then after we've done that, we need to set the power to our motors, tell it how fast we want to run to that position. And finally, we need to tell it to run to position. And this is very important. If you don't have run to position mode, then the motor won't ever run to the position and won't stop there. And it is important for you to have in your code. And finally, I also have this while loop that checks if any of the motors are busy, like if they've reached their position as yet. And this is also used for troubleshooting. So I can find out if maybe one of my motors hasn't reached yet, and I can use telemetry to figure out what is going on, if there are any problems with my motors or anything with my code. And finally, we just set the power to 0, and that finishes our method. So the takeaways from this is basically we figured out how to calculate distance needed to travel, which would just be in relation to the rotations needed of the wheels by the circumference of the wheel. We can combine those values to figure out how many ticks counts are needed, which is basically the amount that is outputted per revolution of the motor. And you must also ensure to keep in mind of your drivetrain specific, the motor, the encoder, and as well as any gear ratios you might have. Thank you for watching this video, and if you have any questions or concerns, please leave us an email or a message in any of our contacts listed below in the description. Thank you for watching, and I'll see you guys next time.